Whoa. Oh no, I better do math right here. Do I get a 9x from that? Why is that wrong? It should be 11, right? Because we get minus a minus, which is a plus. We better get 11x there. And the reason for that is if we don't end up with remainder 0, we've done something wrong, right? Because definitely we should get remainder 0 here because f of 1 is 0. So this gives me 11, so I add plus 11 here. So we get 11x minus 11, and subtract here, and that gives us remainder 0. All right, so what do we have? Thus, f of x is equal to x minus 1 times what? Times 3x squared plus x plus 11. Now, we're asked to factor completely, right? That's ambiguous because I haven't told you completely what? Completely over the real numbers or completely over the complex numbers. Let's suppose we're doing factoring completely over the real numbers, all right? Because there's hope that will be done. My question to you is 3x squared plus x plus 11, is that prime? How can we check? There's two main ways to check if that's prime. The one is to do completing the square. All right? So we could complete the square on the quadratic factor and see if it works out to being a square plus something. If it does, then it's prime, right? Or we could check the discriminant and see if the discriminant's negative. What's the discriminant? I've done that less, but another way to check if this is prime, remember? So this is, this is ax squared plus bx plus c with a equals to 3, b equals to 1, c equals to 11. And the theorem said what? The theorem said this is prime if the discriminant, which is b squared minus 4ac, is less than 0, right? b squared minus 4ac is the thing that appears under the square root in the quadratic formula, right? And so when that's negative, that means the complex formula gives you complex number, which corresponds to the case that it's a prime polynomial because it has a complex factorization, not a real one. So I think for this problem, that's probably easier just to check the b squared minus 4ac, right? And so what is that here? 1 squared minus 4 times 3 times 11. Whoa, that's really negative, right? Definitely 1 minus a huge number is negative. Therefore, this is prime. This is prime, right? And since that's prime, we're done. If you'd like, I can show you how to complete the square on that. Anybody? Nobody? All right, well, let's move on and do a different problem then. So this problem's done. That's it. That's the answer. It's completely factored because that is this quadratic is prime. We can't break it down further, right? Now, if instead I'd said completely factor over the complex numbers, then you'd have to, either use the complex zeros theorem or, complete the square and do something kind of like we did in the previous example to break it down. But let's see here. Let's see if you guys can help me out here. How about we want to find a formula. Let's suppose we've got vertical asymptote here at x equals minus 8. We've got another vertical asymptote here, let's say at x equals to 3. All right. And suppose the graph looks something like this. Whee! Just a second, let me make sure that. Yeah, I think we can hack this. All right, so that one's going to be -5. And I'll say this here happens at 1. All right, and just to set the scale, let's suppose that the y-intercept right here is at, I guess it's at 1 as well. All right. So here's the question, y equals f of x. What's f of x? Can you find me an f of x which would reproduce these features? So this is a different version of like the build a polynomial question on the quiz, right? Except with the rational function. So let's walk through it. Like, so you guys help me out here. I'll do the easy part. To get this x-intercept of -5, you want to bounce. So I'm going to do x plus 5 squared. I want a crossing at 1, so I do x minus 1, right? And I know I'm going to need some wiggle room. I'll put an a up there. That way I can adjust it to move the y-intercept up and down. How do I get the volcanoes that I have in this graph? How do I get this x minus 8 volcano? What do I need in the denominator? I need a x plus 8, right? And it needs to be squared, because that's how we get volcanoes, is when we have like a division by a squared factor. And this one, I'll do an x minus 3 squared for this. And that should do it, because we have fourth order downstairs, we have third order upstairs. So the horizontal asymptote is y equal to 0, which is what we're looking at, right? And all that's left to do is to figure out what the value of a is. How do we do that? Simplify it. Ooh. Oh, I would not do that. I would not do that. What tells us what the value of a is here? Like, what information?
Isn't the horizontal asymptote?
Isn't the horizontal asymptote what?
If there's a horizontal asymptote, would it be the ratio of a?
But notice that we have third order upstairs, fourth order downstairs. So now you're right. If we had like fourth order upstairs and fourth order downstairs, absolutely, then a over the leading coefficient of the bottom would be the horizontal asymptote. That's true, but here it's easier than that. It's not that. So you notice the one thing we haven't used yet was what? This right here, right? What's that tell us? That tells us that f of 0 is equal to 1, right? So that should fix the value of a. See, because f of 0 is what? Plug 0 in. See, the point is I don't need to expand it, because I'm just going to plug 0 into it. And it's much easier just to plug 0 into this formula than to multiply the formula out. Yeah. So like plugging 0 in, I get a times 0 plus 5 squared times 0 minus 1 over 0 plus, and I don't really need to write all these zeros here. I'm just writing it so you can see what I'm doing, hopefully. And so I got like 25 upstairs. And downstairs, it looks like I got 64 times 9, which is like 640 minus 64. Thinking 576, I think. So if this is all equal to 1, what's a equals to? Solve for a, right? So apparently a equals to 576 over 25, which is nothing particularly pretty. And so we can make our answer 576 over 25 times, x plus 5 squared times x minus 1. I'm just plugging a into the formula we already had. That's all, guys. So there you go. That's the f(x). No, when I make a problem up on the test, I usually play some kind of game where I make most I make most of this number cancel out with whatever I put here, because I don't like my answer to be 576 over 25 for A, because it's, you know, just asking for trouble. Oh, sorry. Yep, time to go. Thank you. See you Thursday.